Who am I? Why am I here? No, this is my tutorial on GTK4 slash GObject in C. This is part 1, and this is actually a re-recording of part 1. Some time ago I did do a recording of part 1, and there were a few errors made that I corrected using firstly with an errata and also with a part 1b, but I just thought to myself I really wanted to redo that so that there weren't errors in that video. And so here it is. I will keep the old version online. I'll call it old version in brackets or something like that. And I will also keep part 1b online because I think that it is still a useful demonstration of some of the problems that you can run into if you do some of the errors that I did in the prior version. So with that out of the way, let's talk a little bit about what this series will be, what it kind of is and what it isn't. So what it is an introduction to object-oriented programming in C with GTK4 and GObject. So that's a bit of a specific intersection of topics. But the reason why I decided to create this series was because when I started a couple years ago with this stuff, I had a lot of trouble wrapping my head around the context, really, as to how all those concepts all fit together. And indeed, I've noticed in the past 2 years of just hanging around the GNOME community, a bunch of newcomers have come in and have said, okay, look, I've read the GObject tutorial, I've read the GTK tutorial, but I just don't get it. I just don't understand this GObject stuff and how to wrap your head around it and how to tap into it. And so I thought that by talking about the fundamental basics of GObject and applying those concepts to GTK4, that we could get a unique tutorial and hopefully helpful tutorial series going. So what this series is an intro to GObject, because really we're going to start from scratch and talk about the principles relatively slowly. Although I do recommend watching Christian Hergert's video first on intro to GObject, because it is an intro that is specific to GObject itself without getting into the GTK stuff. But it is a little bit outdated, but I still recommend it because of the nature of what it's about. But we will incorporate the 3 fundamental components of GObject in this series, which are methods, properties, and signals. And so in a sense, it's an intro to GObject, but it is applied to GTK4. So if you're interested in getting into maybe GStreamer hacking or something else that is something that utilizes GObject but not GTK, then maybe this series isn't for you. But what it isn't, for sure, is an intro to C. You do need to know the basics of C in order to wrap your head around this series. And it's not an intro to GTK4 in the sense that I'm not going to tell you, okay, this is a window, this is a label, this is a button, and here are all the methods and properties that and functions that you use in order to understand those things. First of all, I don't think that's a particularly useful exercise, because nobody's really coming to the forums and saying, I'm having trouble making a button and putting it on the screen. People are more so having difficulty understanding tapping into the GObject system and maybe how you do a custom widget, for example. And so that is really why I decided to focus the series on that intersection of topics and not a high-level introduction to GTK as a whole. And plus, there's tons of other videos that do talk about that, so you can feel free to watch one of those videos. Okay, so let's take a look at what we have here. We have a GitLab repo, which I will post a link to in the show notes, and basically it's called the GObject Fun GitLab repo. And then there's a couple of subdirectories in here. You're going to want to go to YouTube tutorial /1. Let's see what branch we're on. Great, we're on part 1A. That's where we want to be. I'm going to make clean because I'd actually already compiled this stuff before we started. And I'm on part 1A, so these chunks of code that we craft here are split up into 2 subparts to break up the discussion a little bit. So first what we're going to do is we're going to do the bare minimum needed to get a custom widget, a blank widget, up on the screen. And then we're going to expand upon that and make the custom widget be a button. And it won't do anything, but we're going to then have to incorporate what's called the destructors of GObject and kind of finish off our initial discussion of how GObject works. So we won't do any custom drawing today, but we will get a basic GTK custom widget up on the screen, and we'll learn how to clean up after ourselves and get it off the screen cleanly. Okay, so let's just take a look at what the part 1a looks like, and we've compiled it successfully. A couple of warnings that we're not going to worry about right now. And so initially in the repo, you've got the make file, the C file, the H file, a main.c file, which is just a stub that'll basically just plop a window on the screen, put our widget in it, and show it. That's it. The tags file won't be there. I just created that using ctags in order to be able to jump up to the definition of certain things I'll show you in a moment. If you do want to create your own ctags file that mirrors mine, I'll post a link in the show notes as well that tells you how to go ahead and do that. So let's go ahead and launch our initial demo by doing /main. You see right here, we've got our window. This guy right here is technically our blank widget. Doesn't do anything. Nothing happens. We just close the window. But that technically is a blank custom widget. Okay, so how do we do that? Well, start out with our make file. Won't spend too much time on this. It's pretty boilerplate. We put the pedantic flag in there, which we may want to get rid of later on, but let's keep it in there for now. We've got our all warnings and our extra warnings. Again, might want to pare those down later, but for now, let's keep them all on. And you'll note that I've got an LD flags here that puts a package config --libs in here. In the prior version of this video, these were one line here and there was no LD flags. So you'll note that in the next couple of parts, there is no LD flags line, but a couple people have complained that their compiles weren't working, and so that's why I modified it thusly in order to hopefully solve those issues. So if you're, hopefully by the time you're watching this, if you get to parts 2, 3, and so forth, and you're seeing that there is no LD flags line in your makefile in those parts, hopefully by that time there will have been an update to the repo, putting a comment in there saying what to do if you're running into problems. So all we do is we're going to take the code for our widget and put it into a .o file, which will kind of be like a shared library, and then we're going to link that to our stub, which will be the main binary file, which will then, like I said before, just get our widget up on the screen. Okay, so that's really all that is, and our clean rule here will just delete the object file and the binary. Pretty straightforward. I'm not really too concerned about the make files looking very pretty. The make files are just to help us get some initial code built quickly, that's all. So the first thing that we're going to want to do is talk about our header file, because that will define our public API that people that are library users will use in order to craft and utilize our custom widget. So first we have we have a mode line here, which will just tell Vim how to display the file. You don't have to worry about that too much. I use Vim, so I want things to look a certain way. That's why I have it. Pragma once, or pound pragma once I should say, is the newfangled version of the header guard that will basically just say if multiple source files in the compilation try to include this .h file, usually you get errors or warnings saying, whoa, you've redefined things that you shouldn't have been redefining. And so the pragma once just says only allow that file to be included once, and then that'll avoid those errors. Pound include GTK/GTK.h just says pull in the GTK headers, which we obviously need to have because we're using GTK. And so you're going to have to make sure that you have your development libraries for GTK4 installed on your system, as well as, of course, the C compiler and GNU make. So the G begin decals and the G end decals, don't worry too much about it. Boilerplate. What it is, I'll show you. It expands out to extern C open curly brace, and for the end decals, close curly brace. So what that basically means is if you're in a C++ compiler, it will turn off name mangling and keep your symbols in the C style when you're actually compiling things into like a library or an object file. And that's important when you're using GObject in C++ code. And so it is typical just to throw those in there, even if you're not ever intending for your code to be used in C++. It's good practice to keep them in. So just think of it as boilerplate. Just put them in there. Don't worry too much about that though. Then, in order to get some boilerplate code essentially generated in order to create a custom widget. We need to use one of two macros, or at least for now what we can think of as being one of two macros. There's GDeclare final type and there's GDeclare derivable type. Now, GDeclare final type creates what's called a final GObject type, which means it can't be subclassed further. That's the end of the road for our demo widget. A derivable type is one that can be derived further. Now there's two reasons why we're using a final type. The first is that it's just a simpler type to wrap your head around, so that's a good thing, at least to start out with. And second of all, the documentation is pretty clear that if you're not really sure what you want to use from the word go, use a final type, because you can always convert that to a derivable type without breaking EBI, but you can't necessarily convert a derivable type to a final type without breaking EBI. So two reasons right there to start with a final type. This is a macro. I can show you what it expands to, but you may be a little scared if I do so. Basically, it puts a whole whack of boilerplate code in there that 20 years ago, for example, you used to have to put in yourself, but now the macros do that for you. And because of C limitations, we know we want to create a final type, and we know that that type wants to be called demo widget, and we know that it wants to derive from GTK widget. So that's why we put the first guy in there, and that's why we put the last guy in there. But what are these guys in between? Well, it's really just a wart in C that there's no way using C macros to sort of create these different capitalizations of these tokens, and so you have to manually punch that in multiple different formats. So be consistent. Don't go around and don't be around getting creative and call this guy blah blah blah, and then while you've got these guys as demo in the widget, keep it consistent. Otherwise, things will work, but they just won't work as expected, and as your users will expect them to work, and so that's not a good thing. And then the reason why we put this pound define here, demo type widget that will expand to demo widget get type. So the demo widget get type function will be crafted for us automatically by this macro here. But the problem is you can't put a pound define in a pound define, and we already know that GDeclare final type is a pound define. And so we have to manually put our pound define there, demo type widget right there. It's just boilerplate, so just do it. You could leave it out technically, but then everywhere where users might expect, like as they would be able to do a GTK type widget, for example, to grab what's called the G type, which is basically a number that identifies it's a unique identifier for the GObject type that's sort of created by the GObject system. So people might think to themselves, well, I can put GTK type widget, so why can't I put demo type widget, for example, knowing how the nomenclature of the demo widget works. You might confuse people if you don't put that guy there. So we're going to keep it in there so that in order for somebody to grab the G type of our GObject, they can utilize this token right here. Good thing to do because people will expect, just like I showed you with the GTK type widget, to be able to do. And then you're going to put your method declaration here. The macros will not create that for you. You're going to have to do that yourself. And so you've probably seen functions like this, for example, GTK label new. You've probably seen a lot of functions within GTK, if you've utilized some GTK, that have the type followed by underscore new. So we're basically doing the same thing right here with our custom widget. And then you're going to see in a couple minutes how we go ahead and define that in our .c file. So that's all there is to it with respect to the header file. Now let's see what the bare minimum is that we need to get a custom blank widget going. So there's a whole bunch of comments in this file. It may actually help when you're doing this for the first time to read them, and then maybe delete them as you go. Okay, and that's probably a good idea. So this is a very, very annotated .c file, which will tell you kind of, for the most part, what each line does. So I'll try not to talk you through all of that, but I will talk you through most of it. But just be aware, you can always go back and look at these comments later on. They're not going away. They'll be there in the GitLab repo. So the first thing that we do is we pound include our own .h file, of course. And then we want to go ahead and define what the guts of our object will be. So what you do to do that is you create a struct. And you need to follow this format. It's got to be struct underscore this guy right here. Okay? And then you put your curly braces, and that's because what the GDeclare final type guy did there was it already created a typedef struct for you, and so that's why you're going to start to just be able to use demo widget without the struct underscore because that happened behind the scenes for you. But you need to follow this format in order to define what the guts of your object are. This must be there. And so what you do is the first item, the first member of your struct has to be a non-pointer to the type that you're subclassing. So in this case, we're subclassing a GTK widget, so you've got to put the full struct guy in there. And if we actually walk our way up the hierarchy there, you'll see that all a GTK widget is a typedef struct to underscore GTK widget. And so we know that a GTK widget is really a type of struct. And so we want to put the full struct in there because the way that GObject works behind the scenes is that it relies upon a feature of the C standard that says that a pointer to a struct is equivalent or can be cast equivalently to the pointer of the first member of a struct. And so GObject relies upon that to be able to walk up the hierarchy. And so you've got it has to be there. If you put a pointer, it'll actually probably compile, and then you're going to get some really weird runtime warnings, runtime errors really coming up that you're not going to be able to understand. Then you're going to rack your brain for hours, and you'll come back and you're finally going to realize you put a stupid star in there, and that's what's causing the problem. So don't put a star in there, otherwise it won't work. But your other guys in there will have a star that we'll see once we move to 1B. Once we move to the next chunk of code that we'll add on to. So that's how that works right there. We're not going to have any custom meat and potatoes. It's just going to be blank widget. That's why we don't put any further members of the struct there. All we do is put the parent instance. And then once we've done that, we go ahead and use this macro here, which is called gDefineType, which is sort of the C equivalent of the GDeclareFinalType type macro that we use in the .h file. First two parameters are boilerplate. They have to just be these two types of capitalizations of your class, of your object, I should say. They have to be there. Just follow that format. But the third parameter is something that is non-boilerplate, and it is the G type. The G type of the guy that you're subclassing, of the GObject type that you're subclassing. So it has to marry up with what you put in here. So because we put GTK widget here as what we're subclassing in the .h file, you've got to put GTK type widget here so that it will work properly. And so make sure that those match up, otherwise, again, not going to work properly. And then what we go ahead and do is put in our method declarations, or definitions, I should say. Two method declarations are mandatory to be defined in your .c file. It's going to expect you to define two types of functions, your instance init function and your class init function. If they're not there, it won't work. So the instance init function, this actually tripped me up first, has to be called your guy underscore init, not your guy underscore instance init. So that tripped me up at first, so just be aware of that. And what that function must take is a pointer to your own type of object. And it's customary to call the parameter self. We're not utilizing it yet, but that's what it's customary to call it. You could call it this, you could call it, you can call it fluffy if you like, and it'll work. But you might as well just call it self because that is idiomatic, and that's what your users will probably be expecting to see. Or anybody that's looking at your code will be confused if you use something else. But because we're not going to do anything, we're going to leave it blank. So the instance init function basically is what is called automatically by GObject. Anytime a new instance, anytime a new copy, I guess you could say, of your object is being crafted. Whereas the class init function, which is the other type of function that must exist, and it must follow this prototype here, and it must follow this naming, your guy followed by underscore class in it. Has to be that, otherwise it won't work. And it takes your guy class, all one word, all camel case, has to follow that format. That's all been expected to be there because you ran the macros. If you put something else, it won't work properly. So keep it like that. And this is this class init function is automatically called by GObject only the first time that your class is ever utilized within code. And so that's the difference there. But really what you'll find is that there's just certain types of GTK functions that need to be called in the class init function versus the init function, and you'll just kind of come to realize what those are the more you start to work with this stuff. And so you may wonder, why is it class with a K? Well, that's because class with a C is a reserved word in C++, and so you probably don't want to clash with that. You can call it G class if you'd like to, or something else. But for years and years and years, people have been putting class with a K there in these class init functions, so I would just keep it like that to be consistent with lots of other code that's out there in the wild. And then those are the only functions that are mandatory to be there. They don't need to say anything, they can just be blank, but they have to be there. And so we've defined them, we've kept them blank, and then we need to go ahead and actually define our public function to basically be the public API for somebody, a library user, to create an instance of our object. And so we already defined that manually right here in the .h file, and here's where we're actually defining that function. So obviously, like any C function that's being defined when it's been previously declared, it has to follow the same prototype, of course. And all it does is it calls the GObject new function and returns it as a GTK widget star. For C convenience, the GObject new, which is a built-in function, not built-in, but it's a standard GObject function. It's part of GObject. It's not something that was generated by the macros. It's part of the GObject library. It actually returns what's called a G pointer, which is a generic void star pointer, essentially, type deft. And that allows you to be able to easily return whatever you'd like to. So in this case, a GTK widget star without needing some casts. So that's really for C convenience, but really what it does is it returns a GObject, which we are implicitly casting to a GTK widget star, which is typical. Because, for example, if we called GTK label new, it wouldn't return a GTK label. It would return a GTK widget. And so, for consistency's sake, we're gonna return a GTK widget too, because that's standard. That's idiomatic, so we're gonna do that. So the GObject new takes the G type of your guy that you wanted to create a new GObject of, and then you could, if we had any, you could specify properties within here to initiate. We don't have any, so we're not going to put anything here. And then once you're done specifying properties to initialize, you put a null in there. So because we don't have any properties, we're just going to put the G type followed by null. And what it'll do is when somebody calls demo widget new, it'll return a new instance of a demo widget as a GTK widget, right? So it'll act just like any other subroutine that comes with GTK in terms of crafting a new widget. So that covers that. And then really, our main.c file is really the most straightforward of all. It's basically very, very boilerplate, almost cut and paste directly from the GTK website in terms of getting the GTK application going. We connect to the activate signal. Again, boilerplate, cut and pasted from the GTK website. And we pound include our demo widget.h file because we want to use our custom widget, and that already pulls in the GTK header, so we don't need to do that twice. And what we do is we're going to create a window and a variable called window, and a variable called demo. And in order to instantiate our window variable, we're going to call GTK application window new to create a standard GTK application window. And then what we're going to do is we're going to use the function that we just crafted called demo widget new, and we're going to set demo equal to that guy. And then we're going to use standard GTK subroutines, and we're going to set the child of our widget to simply be our guy, the demo widget. And then we're going to call GTK widget show just to get our window up on the screen. So everything is just as you'd expect it to be, except that the one difference is that we're using a custom widget, which is our demo widget right there. And so we've already showed what that looks like up on the screen. Not very interesting, but if we run that again, and if we pop open the GTK inspector by doing Control-Shift-I, and if you go to this little guy here and you click, it'll actually show you demo widget. It knows what it is. If I go to miscellaneous, it knows that its type is demo widget, and so it's not calling it GTK widget or something else. It knows that it's a demo widget. And so, and if you actually go up to the hierarchy here, it's calling it a demo widget. So we've notified the GObject system knows that there's a new type of widget that's in the wild now called a demo widget, and the inspector is now aware of it. So that's pretty nice. So we're going to close the inspector, close our window, and now we're going to expand upon that code. We're going to git checkout part 1b, and then Vim is going to complain that we've the files have changed under its nose, and so that's fine. Now we're back to the code as it was before. Main.c has not changed. Demo widget.h has not changed. All we've changed is demo widget.c. So let's go through that. So first of all, we're going to create two new private methods called demo widget dispose, demo widget finalize. You don't actually have to call them that, but what these will be once we define them will be our destructor functions, and so we might as well keep the same format as the constructor functions. Otherwise, we're just showing off that we know so much about GObject that we're going to break the rules, which is just not really something that we're going to be doing. And so we're going to keep it consistent. So let's scroll down. Now, you'll see everything's the same, except we've added here some custom meat and potatoes. All we're going to do is put a pointer to a GTK widget, and we're going to call it button. So that kind of gives a hint to us that we will be putting a button in there. And so that's what you do. When you start adding custom elements to your GObject, and if it's a final type, then you'll put it in your struct of the instance right there. And so that's how you do that. And so note that this guy is a pointer, whereas this guy is not a pointer. So your custom meat and potatoes will be pointers, typically, or you could have an integer or different things that aren't pointers. But when you're putting something like a widget or something GObject oriented, it would be a pointer, whereas this parent instance guy is not. So just be aware of that. Nothing has changed here. Now, because we now want to plop a button in our guy, we do need to put some meat and potatoes into the constructor function, which is our init function. And so all we do is first we're going to create a shorthand, which you don't have to do, but it just avoids some casts later on, which will basically just mean when you see this token widget in here, only within obviously this method, make that be self cast as a GTK widget, so that you don't have to keep punching in all that capitalized stuff right here, for example. Not necessary, but it is a useful shorthand, especially if you start adding more and more stuff to your init function. You're going to find that a lot of these GTK functions that you're calling want to take a widget, and then this avoids some casts. And so all we do is self arrow button is equal to the standard GTK function to create a button with a label. We're just going to hard code hello world to be the label for now. We'll set the age expanded true so that it blows up with our widget as a whole. And now this is important. GTK widget set parent to make that button be a child of our guy. And again, that takes a GTK widget star, not a demo widget star, and that's why you need to pass this shorthand to it, and in order for it to work. Okay. If you don't do that, it's just gonna that button will just exist in a vacuum, and it won't show up, and it will basically be a memory leak. So don't do that. Now there's two stages to the destructor process. So now we've defined these two methods here, the dispose and the finalize methods. You can call them anything you like, but let's keep them in line with the prior things, demo widget underscore dispose and demo widget underscore finalize. Now, basically, why are there two stages to the destructor process in GObject? The short answer is because reasons. There just are. No, if you want to know more about why that's the case, you can click on this link right here. It explains it, but basically, part of it has to do with the way that signal handlers work in GObject, and part of it has to do with what's called cyclical references. You don't need to worry too much about that, but what you do need to worry about is the fact that you need to assume, as a programmer, that the dispose function may be called multiple times. Why is that important? Well, GObjects are what's called reference counted, meaning that they're not just created and destroyed like other things. As more and more things sort of grapple onto them, so to speak, they ask for the reference count, it's called, of that object to be incremented. So when something is first created, it'll have a reference count of, say, 1. But as more and more things take ownership, quote unquote, of that object, the reference count will be incremented to 2, 3, 4, and so on and so forth. And then when you unref a reference counted object, it'll then decrement that reference count. It'll go down, 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 down. And once that reaches 0, it'll then free the memory, and it'll then release the resources. And so if your reference count is, say, 1, and so it should be, but the dispose function gets called 5 times, and again, you have to assume it could be called multiple times, it'll reach 0, and then it'll keep being called again and again and again, and then you're going to get some errors on the screen saying this object no longer is valid. And so then your users will start to complain to you that your program or your library is spewing error messages on the screen. So that's your problem. You have to deal with that. So the gclearPointer function is a very useful function that makes that easy for you. So what it does is you pass, it takes a gpointer star, so which is basically a void double star. So you have to put, in this case, we want to unref cleanly our self arrow button, which is our only GObject that we have as part of our struct. And so we pass the address of self arrow button, and then it takes what's called the gDestroyNotify function, which is a freeing or an unreffing function. And in this case, the function that we call to decrement the reference count and decouple the child widget from our parent, which is our guy, demo widget, you call GTK widget unparent on that. And so what happens is it'll call that on self arrow button, and then it'll set self arrow button to be null. And what happens is if you call a gclearPointer on the address of a null pointer, it'll just do nothing. It'll say, okay, done, don't have to do anything. I'll just skip that and move on to the next thing. And so what will happen is the first time that you run this guy, the dispose function, it'll decrement the reference count and free the memory, but it'll also nullify the object. So if this dispose function is called multiple times, if it's called again, it'll see that self arrow button is now null, and it'll just silently do nothing. And so that's how you get around that issue right there. So if you look at a lot of custom widget code, you're going to see gclearPointer coupled with GTK widget unparent being used in the dispose function. And then what you need to do is put this boilerplate virtual function call right here, which is called chaining up. So So what that basically means is go up the hierarchy to your excuse me, to your object's parent class and call its dispose function. And then guess what? Its dispose function is going to do the same thing and keep going up the chain until everything's dealt with. And so this token right here, demo widget parent class, was created for you by the macro, so it will be there. But because the dispose virtual function is part of the GObject class struct and not of the demo widget class struct, which you don't even have access to. You can't even see what that is because you've used a final type and it's all been done for you. But in any event, the dispose virtual function is not part of your struct. It's actually part of the GObject class struct. So you have to cast this guy to a GObject class to call the dispose virtual function, and it takes, I believe, a GObject star, and so that's why, yeah, it does. And so that's why you pass object, which is the parameter that's actually passed automatically by GObject to this method here. And so don't overthink that. Just you have to put this guy in here as the final part of your dispose function as boilerplate. And the same goes for finalize, which if we had something that was not reference counted, like a string or a file star pointer, for example, it's not reference counted, so we would put it in the finalize as opposed to the dispose function. But we don't have anything like that at this stage, so we've just left it blank. But we have put our boilerplate code here to chain up to the parent class and call the finalize virtual function. Again, we do have to cast this guy here to get access to that virtual function, and then we call the finalize on the object. Don't worry too much about it. It's boilerplate, just cut and paste, got to be there. The class init function, we already talked about what it is in terms of within the GObject system and when it's automatically called. But now we have to put some meat and potatoes in there. Before it was blank. And so a few things that we do. 3 substantive things that we do here. The first is just we're doing another shorthand just to avoid some casts. So we've got demo widget class, which is class with a K, but then we want to be able to have quick access to our class cast as a standard GObject class. So we put this guy right at the top just to establish our shorthand as object class to do that. That allows us to easily override the 2 virtual functions that we want to override, which are the dispose and the finalize virtual functions. And we set those as demo widget dispose, demo widget finalize, which we've already defined above. So you're basically swapping out the virtual functions for our customized guys, which will basically be passed in as function pointers that follow the prototype that it needs. If we had or mal-defined the prototypes for these guys, we'd be getting an error at this stage saying, you know, it's not taking the parameters that we're expecting. So that's what that is there. If we don't do these 2 lines here, then our dispose and finalize functions won't be customized to what we've specified above, so it's got to be there. And then here, this is a standard GTK function that's called on a GTK widget class. And what this does is it tells our widget what type of layout manager to use. There's a bunch of layout managers that come with GTK. You can actually create your own as well, but we're not going to do that at this stage. We might never do that in this series, to be honest. But we're going to use one of the ones that comes with GTK, which is the box layout, which is a good default. So it'll act like this will basically make our custom widget act like a GTK box does, if you've ever utilized that within GTK. So what it does is it takes a GTK widget class, so we cast our class with a K to that by using this macro here, and then it takes the G type, right, of the layout manager that we want to use. If we don't put this guy in here, it's not going to know how to actually arrange our widgets, and we just won't have anything popping up on the screen. So you've got to put something there, or you've got to do things the GTK3 and earlier way, which is to override the, I forget if it's called the size allocate or the allocate virtual function, but that's actually quite complicated to do. So it's pretty nice in GTK4 that we don't have to do that, and we can just specify a layout manager. So that makes life quite a bit easier. So basically, you can experiment with things like this or any code. See what happens if you comment it out. Things won't work properly. But so we'll keep it in for now. And then the rest of the C file is exactly the same as it was before. So that's great. So let's make sure that, well, we know that we're in part 1B. Let's just make sure we are. Yes, okay. So let's make clean. Let's make, let's run our /main file right here. And then you'll see here, it's the same as it was before, except instead of a blank widget, we've now got a huge GTK button. But this still is technically a custom widget. It just doesn't do anything. But at least it now has a button that shows up, so we don't just have a blank window on the screen. If we pop up the inspector again, you'll be able to see here that if we expand the arrow for demo widget, you can actually see the child in the inspector being the GTK button. You see how it shows the hierarchy there? You see the GTK button is a child of the demo widget. So that's pretty cool how you can visually see that. So again, it knows demo widget exists, it knows GTK button is a child of our guy, and everything's working really nicely. So does this customized widget do anything? No, it doesn't, but at least it shows some of the fundamental basics of getting a custom widget started. And really what we've done is essentially created a very, very stripped down composite widget, which basically means a composite widget as opposed to a custom drawn widget. Just means that you're taking pre-existing widgets within GTK and just incorporating them in a customized way amongst our widget. We will get into some custom drawing in a future episode, but we're not ready for that yet. We're gonna, in the next episode, talk about the next couple of episodes. We'll talk about adding properties and signals to our object, and then we'll take things from there. So that hopefully that's a good introduction for people to GObject within the context of GTK4 and how you start out by creating a custom widget. If you have any first of all, you should certainly fetch the GitLab repo. But if you've fetched that, you've read everything, you've compiled everything, if you have some questions, feel free to post them in the comments below. Don't forget to smash that like button, or don't if you don't want to. Nothing's monetized here, folks, so do what you want, but just provide feedback if you have questions. And I appreciate all the people that have been viewing these videos and will be viewing these videos and that have provided their feedback thus far. So thanks again, everybody. Good night and good luck.